Manuel. My name is Markus Heseding. Welcome to our seminar from ISTMA today. I would like to first introduce myself. I'm Managing Director of Precision Tools in the VDMA, and I am ISTMA Europe President. And I very much appreciate that we have today two experts from DMG MORI. I would like to introduce Michael Kirberth. Michael, if you can just raise your hand to know which of the Michael is a yeah. He is head of DMG MORI Excellence Center Aerospace and Dies and Molds. Welcome. And Michael Kieslich, well, that's for you, it's sure who you are. He's sales manager by Europe for the EMEA region. Also, welcome. Our today's topic is, can green transformation increase competitiveness in machining? So, Michael, it's your floor, your show. Please start with your presentation.
Yes, thank you very much, Markus, for the kind introduction. Welcome to DMG MORI in Fronten in the south of Germany. I have heard that we have participants from almost all over the world, so we are meeting now in the south of Germany. Very welcome. And for the webinar topic, we thought about asking a question about green transformation and asking the question whether competitiveness is possible in machining by going on this transformation. So we will do the presentation together. I will start with some general overview and our product strategy, and then my colleague, the other Michael, will go in more detail how we can use machine tools more efficiently with less energy consumption. Before I start into the topic, give me 30 seconds to give you a short idea about DMG MORI if you don't know us. DMG MORI is producing machine tools, automation solutions, of course, and solutions for digital and green transformation. We have 16 R&D and manufacturing locations worldwide. So we are here in Germany, in Fronten. We are the second largest factory of the whole group. We have more than 100,000 customers worldwide. I know there are some participants also from South Africa. We don't see Africa on this map, but we have also customers in this beautiful country and area. We have around 300,000 machine tools worldwide operating from our brand, and every day there will be more. In some we are represented in 43 countries with sales, engineering, and service, 113 different locations. So you have an idea what DMG MORI is doing. But let's go to the topic. When customers ask us for machines or intend to invest into a machine tool, of course there are many technical questions have to be answered, size of machine and so on, and a lot of commercial questions as well. But there are other questions which may need also be need to answered, especially the time where we have to look for sustainability and how we can achieve all the targets which we have and the challenges which we have. So we have to think how we can manufacture in the future better than in the past with my old maybe machine equipment. Today the parts also in the die mold industry, in the tool industry, they are more complex. They require a more complex process chain. We have to think how we can do this more reliably and get a better solution for this. Today's machine tools have more capabilities than maybe 10 and 20 years ago. We have to ask ourselves how we can utilize these machine tools better. And of course, we always talk about a gap in skilled people, and especially the young generation. We have to be very attractive in production to attract young people to go into production, to go into manufacturing. And this is also a very important obligation for us. But last but not least, we also have to think how we can make production more sustainable. And this is, of course, sometimes this green question, sustainability, but thinking about the employees, also this is a social aspect of sustainability. So when we answer this question, we also take care of sustainability already. And for the other technical questions, we always can also ask which technology helps us better with our targets in terms of sustainability. So as you already can see, it's mainly a technical question we have to answer to become more sustainable, and then at the end also to become more competitive. In DMG MORI, we have a strategy for this, a product strategy. We call this machining transformation. You have seen on the first slide the butterfly, which is a symbol of transformation, of a journey, of a change. And this machining transformation consists out of four topics. It's the process integration, it's the automation, it's a digital transformation, and the green transformation. And these things also belong together. I make a little example at the beginning. When you have a component, you want to machine this on traditional machines, you may have different steps on different machines. When you use a modern machine, you can do a process integration and you utilize one machine much better than the simpler machines before. So with higher utilization, you already give a contribution to a green transformation. That's always a maximizing of the utilization of your equipment. When you then introduce automation, of course, you increase utilization even more up to 24/7. You achieve better quality, means also less waste in materials, less scrap, less tool wear, hopefully, and better quality at the end is less efforts, which are not really required. But sometimes when you have not a good quality and not a good process, you have to invest in more resources. So also automation gives a contribution somehow to sustainability. These two steps make it a little bit more complex, and you need software, you need the digital tools, and to decrease the complexity of this. And then we are in the middle of the digital transformation where we utilize software, hardware from this. And another example is that this software, you can, of course, make your workflows more efficient. You can get data from the production where you can really see where's your waste, where you spend too much time, too much money, too much resources to make a product. And based on the data, you can better work on improvements. So the digital transformation also has a contribution already to the green transformation. So this concept at the end is a comprehensive concept. But nevertheless, we have to do more on the machine tool, where my colleague Michael Kieslich will then show you what is possible with the machine tool itself. But first, we have to understand the full concept. I have also prepared two examples to show this a little more in detail. When you look to this part, is a camshaft, not a complex part, but when we go through a conventional process chain, in the past, we may have done this part out of 3 different raw materials on different type of machines. We had to have many operators to run the machines. Some of the machines are bottleneck machines. Some of the machines are idle most of the time. This is not very sustainable, and at the end, it's also high costly. When we go to a machine transformation with a modern machine tool where we can do really good process integration, we have the opportunity to make the part out of one raw material, and with a complete integrated process chain, we can do the turning, the milling, the gear cutting, the grinding, only on one type of machine. Means also then we can optimize much better. So we can optimize one machine, but we cannot optimize and link several machines. It's more complex, more difficult. And to realize it, we need digital support here. We need CAD/CAM systems, we need simulations, we need post-processors, and maybe many other things. So we have to see this in a holistic view, and then we can achieve higher sustainability in production. And at the end, this production, which we see on the right-hand side, is more sustainable than the conventional process chain on the left-hand side. I have another example, last example. This is comes from another event. It's a rotation somatic part here, in this case, a turbine disc. You see on the left-hand side a conventional process chain, right-hand side a process integration. We come from 13 operations to 5 operations, from 5 different type of machines to 1 type of machine. We can significantly reduce the time to make the part, also the throughput time in my factory, and I can reduce the cost of my part. So we also can see that this integration of processes makes me more competitive at the end. But we also make a big contribution to sustainability here, because we utilize the one machine much more than the other machines, which are idle most of the time because they don't use them all the time. And we have no bottlenecks. So we have no bottlenecks where we have to spend extra energy to overcome the bottleneck, for example. We can do automation now and even increase utilization. And the process is more reliable now. So we have less waste in material, we have less waste in tools, and maybe we waste other resources also less because of much better processes and a better process chain here. Finally, we have also state-of-the-art technology, which is more attractive to young generation, to young people, because we don't work on old machines. We work on the most modern machine type. With maybe automation, we need good engineers here, and I think it's a very good motivation for a young generation to work in production, because production moves from a old style production to a very modern style of production with latest state-of-the-art equipment. This was just my introduction, and I hand over to Michael Kieslich to tell us more about what we can do in machine tools.
Yeah, thank you, Michael. Energy efficient machining and sustainability. Increasing energy consumption in the production and the rising and fluctuating prices are currently the driver of the green transformation. However, the awareness of sustainability is not only changing in the private life, it's also changing in the world of work and for companies. But let's start really on the top. Here you can see the global energy demand in the year 2018. We had approximately 23,000 terawatt hours. 38% of this will used by the energy, and the unbelievable number of 2% went to the metal cutting machine tools. That's the number 460 terawatt hours. To get a feeling for this, whole Germany in the year 2018 used 547 terawatt hours. So that shows the potential on the machine tools to save energy and to be more sustainable. When we go one step deeper and we will take a look on the machine tool, then you see when you order a machine, normally you will get some planning documents, and in the planning documents of a machine tool, you see the power rating. And this shows that the power rating, that the main spindle needs 51% and the feed axis need 23% of the power rating. But when we take a look on the real and the actual energy demand, it looks completely different. It's important to understand that the energy usage or the energy consumption of a machine tool is always part specific. Is it a lot of roughing? Is it just finishing? A lot of tool changes and so on. So we checked here some simple part, and then we see that the main spindle and the feed axis, so the value adding features in a machine tool, just use 23% of the energy consumption. The rest is going to some other units, like the machine cooling, to cool down the machine, bring the accuracy, the coolant supply, cooling of the control cabinet, or the chip conveyor. So in our eyes, you have actually two options to reduce the energy consumption. Actually, it's three options. I will show this later. It's a quite simple diagram. On the one side, we have the process time. When you reduce the process time, you normally use less energy. How can you achieve this? Like the other Michael said, our idea is MX, the machine transformation. With process integration, you reduce the process times. With automation, you will get higher spindle run times, you will get less downtimes on the machine tool. Digitization with a simulation, or also to find out why is a machine down. This can be done via digitization in the machine tools. And this is a job of the customer, of the worker, mainly. On the other hand, the reduction of the real energy demand of the machine tool. That's our business, but also your business, because you have to use some options. How we do this? We have a smart monitoring. A monitoring will give transparency, will give awareness to the worker, what the machine tool really needs when you produce a part. We have a monitoring to check if we have a leak in the pressured air circuit. We have to build in efficient components, highly efficient chillers, frequency controlled pump, or we are using the brake energy and bring it back to the net. And a big focus topic for us is demand-orientated operation. A lot of machine tool supplier, also we have some smart solutions for a shutdown, automatic shutdown of a machine tool. That means if the machine is not working, it goes to an efficient mode. And last but not least, adaptive coolant flow. And this is the third point, the innovation. And our innovation, I jump over this, and our innovation, adaptive coolant flow. What is our idea? When you take a look on this diagram, you can see the flow rate and the power on the pump, the usage of power on the pump. In this case, the 80 bar in a coolant pump. And with this diagram, you see that the curve is quite steep. That means you want to have a higher flow rate, you need a lot more energy on the pump. And from some point, it makes no sense anymore. Especially with smaller tools, this curve will be much steeper, very, very steep with some tools in this. And then it makes no sense to bring the pump, bring a lot of energy in the pump because the flow rate will not be higher. So the flow rate is now a quite new unit. Nobody knows what is the right number for a tool, the right flow rate for a tool. And for this, we develop a cycle. With this cycle, the machine tool will check the tool on the first usage. So we select everything. And then on the first usage, the tool will come to the machine. The machine will check the tool. And we set the correct flow rate for this specific tool in the tool table and lock this down. And now the customer can work with this. And here the comparison. On the left side with 80 bar machining, the pump needs 5,000 watt. On the right side with adaptive coolant flow, 500 watt. So we have a reduction on the pump of nearly 90%. Also here you can see much less oil mist in the working room area. This is also sustainable. Less oil mist means the vacuum don't take so much coolant flow out of the machine. You don't have to refill so much. That's also very sustainable. And then we noticed as well, especially in deep hole drilling, to machine with a constant flow rate, higher or will give a much higher process safetiness. Again, to get a feeling about the numbers and the potential on machine tools, we have here a comparison. We used our own machine, and we have all our energy saving measures on and off, and made some test parts. And here you can see we have in these test part a specific process. We have a standby, a warm-up, waiting for machining, and emergency stop. And when we use all our measures, you can see in the standby, we save 45%. How we save this? The machine knows that the machine is in standby, and we shut down the pneumatic, we shut down the hydraulic, we shut down the light. So we save 45%. On the machining, we save nearly 40%. This is driven from the adaptive coolant flow. We save 90% on the pump, and all over, or when we look on the complete machine, it's 38%. And quite interesting, the emergency stop, it's quite common that the worker when the shift is at the end, that they put the emergency stop. That's the worst case. The machine is on, the motors are in control, So we compared this, the emergency stop versus our green mode auto shutdown. With this, we save 81%. So huge numbers, and it's quite easy to do this and to select this. That means in a complete process all over, we saved 36%, and that's the number of nearly 8,000 kilowatt hours per year with some calculations. And as comparison, so a normal 4-person's household has approximately 3,000 kilowatt hours per year. Just to get a feeling. But you can start now. You can start now with your machines, with the existing machines. How you can do this? A lot of machine tool suppliers have something like an auto shutdown. That means there is something to select that the machine goes in an efficient mode. Use the process optimization also with your existing machines. Reduce the non-productive times. Why? Finally, a machining machine tool, a producing machine tool is the most efficient machine tool. A waiting machine tool just need energy when it's on. Speak with the operators. If you have a variable pump, variable pump, you have an 80 bar pump, the high pressures are not necessary. The high pressures need a lot of energy. Start with automation. For example, just a 0-point clamping system to reduce the downtimes, and start with digitization. Have a good planning. Find out why the machine is waiting. Is it the raw material? Is it the tools? Just that you get the big picture of your workshop. So finally, what our factory is doing, we also in the green transformation, what we are doing, we put on our buildings, as you can see, a lot of photovoltaic. We started years ago when we built our new facilities with a very efficient heating system. So we have geothermal heat pumps, we have a cooling per groundwater, we have fully climated facility. We need this also to build high accuracy machine tools. We changed everywhere to LED lights. We have a new charging infrastructure in our parking house. We use the heat again. We load the temperatures also in the offices, and the rest of the facilities that are not ready for the photovoltaic, we have greening on this and grass. Yeah, that's the short overview about our idea of the green transformation. Yeah, and I will hand over to Michael again.
Yeah, thank you, Michael, for this detailed technical explanation what can be done on machine tools, and said we don't want to do less production. The answer means we have to do more production on the machines to be more sustainable. So when we started with the question, can green transformation increase competitiveness in machining? As a conclusion, we can say, of course, yes, but you have to do it in the right way. And we have summarized that a little bit here with some words. You have to see the green transformation as a part of an entire mindset change in machining. In brackets, you see the MX is our machining transformation, this is our strategy. But I think every company has to define their strategy, how to be more efficient in the future, utilizing the equipment much better, and of course using state-of-the-art technology. Technology is key driver in sustainability. If you have a production with very old machines with a low utilization, you waste energy in space, in heating of your factory with equipment which is standing around. So finally you have to maximize your resources and optimize it, as we have seen with the new solutions which are developed. And we just had the 2 weeks open house the last 2 weeks, and we had an own area where we showed these green mode technologies. And I think it's not a surprise that many of our customers were very interested in this to learn how they can do this, how they can utilize this in their factories. And yeah, we see that these examples like green mode, of course, there's a lot of research work was going on in the past, and of course now we have the solutions available, and I think there will be even more to come in the next years. When we see this in a holistic approach, not just only the cutting tools, not just only the coolant, not only the machine tool itself, we have to look to the whole process, to the whole process chain. Then we see a lot of potentials to achieve better results, and also what I think we have seen on the adaptive flow control, we even get better quality because we give the tool the right volume of coolant, not too much. So even the quality increases, which also is sustainability, and we can produce the same parts with 36% less energy. And this is a good example. And this was our argument to say, yes, you can become more competitive. Clean transformation is not a burden, not a cost increase. It's an opportunity to become more competitive. And we have also seen our factory. It's also increased your, let's say, branding, or improves your branding when you are doing something like this, and then when you are in your green transformation already. That's it from our side. Thank you for your attention. And of course, we are available here for questions now or also later. Thank you.
Thank you.
Yeah, thank you to both other Michaels. We are open for questions, so everybody is invited to ask questions in the chat function so that we can read it, or raise their hands if that is possible during the Zoom meeting. I have a question to Michael Kieslich. In one of your charts to the green mode saves energy and money, you were talking about, or let's say there was a calculation basis of energy costs per year.
Yeah.
The value was 5,700 euro per year. Is that based on German pricing, or is that based on French or Swedish pricing?
This was an energy cost of 32 cents per kilowatt hour.
I didn't see that. Sorry for.
Yeah, that's very
small.
small. So in this calculation, the calculation is based on 4,000 hours per year, 30% standby, 20% ready, 50% machining, and with the energy cost of 32 cents per kilowatt hour.
I see. Yeah, so that's more or less German values. I see.
Yes.
Yeah, but that's how it is. Yeah, at the moment.
Yeah, of course, when you do the same discussion with customers, for example, in North America, where the electrical energy is far lower, this calculation will be different. Yeah. On the other side, when you think about more reliable processes due to the machining transformation, you achieve better quality. You have less waste of material, less waste of tools, less waste of other resources. At the end, it's sustainability is money. At the end, you have to always translate sustainability in money to be motivated. But of course, in Europe, the driver is energy for us.
And nowadays, everybody shut down the light when he left a room. This was 5 years ago, also different. So there is a mindset change. And there will be a mindset change in the machine tools as well.
For sure. Thank you. Thank you both of you for having this presentation for us. Thank you for being part of this seminar, and thank you for organizing the seminar to Manuel, who did that as the ISTMA General Secretariat. Have a good time, and see you next time on our next seminar. Thank you and goodbye.
Thank you.
Thank you. Bye.
Thank you.
Bye.